Welcome viewers, in this video we will see the solved problem based on the network topology. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Network topology solved problem 4 based on the incident matrix oriented graph. So that determinant of incident matrix of a closed loop is 0. So we need to show that determinant of the incident matrix of the closed loop is 0. Now consider this closed loop having the 3 nodes. 3 nodes are available. Consider this closed loop having 3 nodes A, B and C. 3 branches 1, 2 and 3. So this is called a oriented graph. That is the network. The elements are replaced by the straight line. Then the directions are marked. Only straight lines are allowed, there mean graph. Directions also available mean oriented graph. So we are able to understand how many nodes, how many branches are there, how the current is flowing from the graph. The incident matrix, complete incident matrix will give the value -1, 0, 1, so that we can able to know whether the current is going towards or going away or it is not connected. This detail can be gathered from the incident matrix. So the 3 nodes A, B, C, 3 branches are available. So we are able to form the 3 cross 3 matrix. So first we will form the tabular column. From that, the values available in the tabular column is nothing but a incident matrix. So 3 nodes A, B, C, 3 branches 1, 2, 3. If the current is going towards the node, -1. Away from the node, +1. Not connected means 0. Right? Not connected means 0. Going away means 1. Going towards means -1. Based on that, we can fill the tabular column. First consider the node A. Node A is connected with branch 1 and branch 3. So branch 1 going towards, branch 3 also going towards. Going towards means minus. Node A, branch 1 going towards -1. Node 3 also going towards -1. Branch 2 is not connected, so 0. Then we'll see the node B. Node B connected with first branch and second branch. Third branch is not connected. So third one is 0. So the small correction is there. This is based on the matrix value. This is node B and this is node C. So node A we completed. Node B 2 and 3 is connected. Branch 1 is not connected, 0. At node B, branch 2 going away. Branch 3 also going away, so +1. Node B, branch 2 going away, +1. Node B, branch 3 also going away, +1. Now we'll see the node C. Branch 1 is going away, so +1. Branch 2 coming inside, going towards, -1. Branch 3 not connected, 0. So based on that, we completed this tabular column. This is nothing but a 3 cross 3 matrix, complete incident matrix. So from the oriented graph, we framed the complete incident matrix. Not connected means 0, going towards means -1, going away means +1. Now we'll see the determinant. Determinant of this matrix should be 0. That we need to prove that. The determinant of complete incident matrix of the closed loop, AA refers the complete incident matrix. A means reduced incident matrix. So this is the matrix available. We need to find the determinant. -1 into, we have to multiply this. 1 into 0 minus 1 into -1. 1 into 0 minus 1 into -1. This value is already 0. Anyway, we need to put minus because of interchange. Then the third column -1. We have to multiply these two. 0 into -1 minus 1 into 1. Right. So 1 into 0 is 0. 1 into -1 is -1. Already your -1 is there, so +1. Outside one -1 is there. Second value is 0. third value minus 1 into this value is 0. 1 into 1, 1 minus 1. So here minus 1 into 1 is minus 1. Here minus 1 into minus 1 plus 1. So minus 1 plus 1 finally 0. So the determinant of the complete incident matrix is 0, hence it is proved. So in this video we discuss determinant of a incident matrix of a closed loop is 0. We consider one closed path. From that we framed the complete incident matrix and we calculated the determinant. It shows that it is 0. Hence the statement is proved. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.